All right, the title of my conference paper is Survey of Secure Network Protocols for United States Related Domains. So a little bit about myself, I'm DeJean Dunbar. I obtained a Bachelor's of Science in Computer Science in 2017 at Charleston Southern University. And I am currently a graduate student at Charleston Southern University. In fact, I only have one more semester left until I receive my master's degree. And this conference is actually one step in helping me receive my master's degree. So it was an awesome opportunity to be a part of this. Right now, I'm currently working at Savannah River Nuclear Solutions. I've been working there for 5 years as a software engineer. And I've started off working with the LIMS system, a laboratory information management system. That was known as Labware, commercial off-the-shelf product, with some configuration, some programming beside it using LIMS Basic. And currently I'm right now a web developer using React.js and other tools for greenfielding old applications and making them into newer applications. If there's any questions after this as well, you can always send it to my email, as you can see, dejan.dunbar@gmail.com as well. So some of the key players that helped me with this paper was Dr. Yu Lin. He has a PhD in computer science. He is currently the director of computer science graduate program at Charleston Southern University. And Dr. Lin has always been the type for me, even as an undergraduate. He's always encouraged me, pointed me in the right directions when it came to assignments, projects, and just even my senior project as an undergraduate. So Dr. Lin has been a key player for me for my academics. The second person is Raymond Wilkaskas. He obtained his Bachelor's of Science in Computer Science as well. He actually is my coworker who recently retired from Savannah River Nuclear Solutions. He's worked at Savannah River Nuclear Solutions for over 30 years. So he's pretty much been my mentor and kind of the person to point me in the right direction when it comes to my career. So those two were very influential for this paper as well. So now the roadmap for this paper. So we're going to actually talk about the problem. We're going to address the thesis goal of this paper, an introduction. We'll be talking about US related domains, followed by a proposed scoring system for domains. We'll talk about how the experiment is conducted and how we actually gather these domains and actually scan the domains as well. And then we'll show the results of the scanning of the domains, along with the analysis section and the conclusion. So a lot of things to cover, but we'll get through them one by one. So the current problem, cyber attacks are still prevalent for the internet. So when internet started, we had the HTTP protocol for domains, which had no secure way of handling communications in a secure way. So HTTPS was introduced later, and HTTP, strict transport security. Those two has greatly helped with securing communications at a protocol level. So the question is, are domains taking advantage of the latest protocol versions and features? And more specifically, what is the state of this in the United States when it comes to domains that are United States related? So with the thesis goal, we want to determine two things. We want to determine the degree to which US related domains are configured optimally for HTTP security protocol setup. We also want to create a generic scoring system for domains network security based on the following factors: SSL version, TLS version, and the presence of Hsts. So in other words, the first bullet point will jump us into the second bullet point once we incorporate the scoring system and getting the results of analyzing these domains, these US related domains. So a little introduction about HTTPS today. So as of right now, HTTPS has different support for protocols. So we have the SSL, which stands for Secure Socket Layer, and we have the TLS, which stands for the Transport Layer Security. So the SSL and TLS for HTTPS are cryptographic protocols that essentially keeps the internet connection secure. So you see on the left side, the SSL, and on the right side, TLS. So one question may be, what's with all of these upgrades? What's up with all of these version increases from 2.0 to 3.0, and then from 1.0 to 1.3? So when HTTPS first came out, it came with the SSL, Secure Socket Layer support. So the reason for these upgrades in general was because as each upgrade came out, as time passed along, hackers discovered, hackers unleashed a lot of vulnerabilities for these versions. And one example would be the Poodle vulnerability, which is pretty much the downgrade protocol attack, where the attacker attempts to target a lower version of protocol support in order to invoke its vulnerabilities. And we have other attacks such as the drowned attack, which is just pretty much an attack that's able to decrypt the ciphertext between these communications of these versions. So the best version out there right now for HTTPS is TLS 1.3, and the earliest version is SSL 2.0. So now we're going to talk about the HTTP strict transport security, known as HSTS. So HTTP strict transport security, known as HSTS, is a response header. So it essentially informs browsers that the site should only be accessed using HTTPS. So any future attempts to access the site using HTTP is automatically converted to HTTPS. So HSTS is essentially a layer you put on top of HTTPS protocol. You are not able to use HSTS for HTTP, of course, because HTTP has no security behind it. So we'll talk about why converting HTTP automatically to HTTPS is very important, and why it's also important to have HSTS with this. So we see here in this slide, HTTPS versus HSTS. So we'll talk about two scenarios. We'll talk about a user trying to access an HTTPS related domain without the HSTS on top of it. So this is what normally happens. The user will type in a domain with HTTP, yourdomain.com, and what will occur is a redirect. So the redirect will take the user to a HTTPS related domain with a secure connection. Same website, but with the secure connection. The issue is during the redirect, as you can see in the red box, the hacker can intercept the communication since the browser is using HTTP during that redirect. So this redirect is known as the man-in-the-middle attack. And when a hacker can employ this attack, when the user gets back the HTTPS response, the user will actually believe they're looking at the actual website. But if the hacker was able to intercept it, they can control what the user actually gets back. The user may think they have the correct website and they're entering certain information that's private, but now the hacker have access to that information because of this man-in-the-middle attack. So that's HTTPS without HSTS. So let's talk about what happens if we employ HSTS on top of HTTPS domain. So the user will access the HTTP domain, but this time the browser is aware that HSTS is enabled. So this causes the browser to automatically change from HTTP to HTTPS. So there's no redirect. That's the important takeaway here. There is no redirect that is occurring. It automatically takes the user to HTTPS without a redirect because of HSTS being in the header of the website. So one caveat with this, with having HSTS, is for the first time you configure HSTS for an HTTPS related domain, you have to allow a redirect to happen one time initially in order for the browser to be aware that HSTS is there. This is a one-time and a lifetime deal. So once it happens, you will not have to worry about a redirect anymore. So this is a good trade-off of having only one redirect in its lifetime versus a redirect based on however many times you try to access the site if you don't have HSTS. So next, we're going to talk about the US related domains we'll be talking about. So as you can see, you see these different registrars that's based in the United States, educause, which controls the .edu domain extensions, GoDaddy, which controls the .us domain extensions, and .gov, which controls the .gov related extensions. So these three domain extensions is what we'll be focusing on for analyzing the domains: .edu related domains, .us related domains, and .gov related domains. So we're going to talk about the proposed scoring system for domains. So we want to have a simple way when we're analyzing these domains, a simple way of determining in a numerical sense the state of domain network security strength. So the score we're going to be using for analyzing these domains will be based on the current RFC deprecations for HTTPS protocol versions. So what is RFC exactly? That stands for request for comments. And it's essentially publications that's released by a group called the Internet Engineering Task Force. And that's essentially an organization that standardizes internet protocols. They're the trusted organization for that. So we'll be basing our scoring system off of that. So now we'll talk about the actual scoring system for the domains. So you'll see in this image here, we have three different tiers of scoring. So we have in our tier 1, when domains are HTTP related, we're going to give it a score of 0. And the reason for the score of 0 is because, of course, HTTP related domains don't have anything secure about it. So we want to give the lowest score possible, which is numerically a 0. We'll notice in tier 2, we have HTTPS domains configured with the SSL related versions. Notice in tier 2, we start off with a score of 5. And for each state, we give an even distribution score of a 5. And you can see that SSL 2.0, for example, has a score of 5, but we can also have SSL 2.0 with the Hsts incorporated, which we give a score of 10, and so on until we reach the highest possible version for SSL. Notice in tier 3, we have HTTPS related domains configured with the TLS, the transport layer security versions. Notice between tier 2 and tier 3, we give a increase of a score of 10. And we keep this even distribution score of 10 across each state until we reach the highest version of TLS 1.3 having HSTS, which will give a score of 100. Since that's the most current version out there, we'll give that a score of 100. So one question is, what is considered a passing score? So what I determined is a passing score for this paper is when we have a domain that is configured with TLS 1.2, we'll give that a score of a 70. A score of a 70 is considered passing, 70 or above. So what's the reason that we chose TLS 1.2? Well, there was an RFC publication that was released. It was a RFC 8996, which pretty much announced that it deprecated TLS 1.0 and below. So this deprecation is essentially saying that it is highly recommended you do not use anything lower than TLS, on 1.2. We do not want to use 1.1 or below, essentially. So since that was a released publication, we want to go off the protocol that is you're still able to use that's supported. One reason for the deprecation had to do with the support of earlier cryptographic algorithms. So TLS 1.1 and below used earlier implementations of cryptographic algorithms. Versions TLS 1.2 and above use more modern implementations. So it's encouraged to use TLS 1.2 and above. One thing also to notice with this scoring system is that for HTTPS related domains, which would be tier 2 and tier 3, a domain can actually have more than one support for its protocol version. So for example, let's say we have domain A. domain A could have support for TLS 1.1 and support for TLS 1.2. In that case, we'll take the highest version it supports to determine its scoring. So in this case, for domain A, we would give it a score of a 70 since it can support TLS 1.2. All right, so for the experiment, number one, we're going to scan each of the US related domains, the .gov, .edu, and .us for the SSL/TLS version. And then for number two of our experiment, we're going to scan each domain collected for HSTS header presence. So with 1 and 2 done, we're going to incorporate the scoring system into the results as well and generate some charts of data to analyze the state of these domains when it comes to the SSL/TLS version and its HSTS header presence. So before the experiment, we're going to actually talk about how I actually gathered these domains from the three sources, the .gov extension, the .us extension, and the .edu extension. So for the .gov extension, the .gov registrar on their website actually provided all of the websites from a CSV file. So luckily, .gov registrar kept up with all their websites easily in a CSV file. I went to that website and actually downloaded the CSV file and just extracted the domains from that source for .gov. For the .us extension, I emailed GoDaddy directly with the request for the zone file in order to use for research. And a zone file is essentially a file that contains all of the related domains for a particular extension. After getting that zone file from GoDaddy, I was able to analyze that file and extract only the relevant domains. There was a lot of extra metadata in this zone file, so use some lines of code in Linux as a script to extract the .us domains from that file. So the same technique for .edu was attempted by contacting educalls, the registrar that handles the .edu, but due to their policies and their tight restrictions, they were not able to provide me their zone file. So there were two alternative things done to extract .edu domains. First, I pulled domains from a trusted website called Common Crawl, and this website is essentially a web crawling service which scans millions of websites and stores its information in a repository. So by using Common Crawl's database known as Athena, which is an Amazon-based service using AWS console, I was able to query their data and filter it only on domains that contained the .edu for its extension. So that was my one source of collecting that information. My second source of information was an established GitHub repository that contained edu domains as well. So now we're going to talk about the domain scanning techniques. So once I gathered these domains, what tools did I use to actually scan the information I needed to analyze it? So in order to get the SSL and TLS version for the domains I gathered, which was over 600,000 domains collected, a tool known as SSL Scan, a pretty well-established GitHub repository tool. It's a command line based tool where you can provide as input a file of all the domain names, and what you get back out as output is an XML file, which gives you information about each domain's SSL/TLS versions. In order to gather the HSTS presence in the domain, I wrote a separate Python script that was using the built-in request method for Python to look for an HSTS presence in the domain. It's kind of a similar style where in the Python script, I wrote as input, taking in a file of domain names. And then for each of those files, I would loop through each name and just extract and determine using the Python request method if there was Hsts in it. An additional Python script was also written to process the output of the Ssl scan tool. Since I said earlier that Ssl scan produced as output an XML file, I was able to write a Python script to process that XML file. So these Python scripts that were written when it was able to gather that information, those results, there were update statements written in these Python scripts once the information was processed that actually performed update queries into a MySQL Server database to store all the results for the domain if it had Hsts in its SSL/TLS versions. And MySQL Server database was of course used because collecting over 600,000 domains, there would be no way to remember all of that information. So it was a good place to keep the data. And I was also able with that data to query it back later to generate a lot of different types of graphs for analyzing the results. One last thing to mention about these scripts written is you can imagine that getting information about the domain is a web-related request, which would take time to process for one domain. So I told you all earlier that looping through each one is going to take time to get that information. So you can imagine that having over 600,000 domains, it's going to take a long time to generate this. So a way of reducing the time was actually just to create multiple instances of these script programs in the command line in Linux. So instead of having one file with all the domains, I actually split the file down into separate smaller chunks of files and just ran multiple instances in parallel of these scripts in order to reduce the amount of time it would take to get all this information. So now we're going to talk about the results. So with over 600,000 domains analyzed, we see that in this chart, we're going to look at HTTP versus HTTPS. How many domains had that protocol? You can see that 62% of domains had HTTPS protocol enabled, while 38% had HTTP enabled. So about 2/3 of domains analyzed for US related domains contained HTTPS protocol. So the results for protocol type detection. So as you can see in this chart, this is pretty much the same kind of comparison as in the previous chart, except we're breaking down the HTTPS related domains down into its individual versions. So you'll see that the highest amount of domain presence with TLS 1.2 was TLS 1.2 with 62% of domains having TLS 1.2 configured. You'll also notice that the lowest amount of domains was for SSL 2.0 and SSL 3.0. So we'll talk about why that's the case. So one reason behind such the low amount for SSL 2.0 and 3.0 is these versions were released back in the late 90s. So it would make sense that with all the time that's passed, that it would hardly be any domains left using these types of protocol versions. It's not safe anymore. There's lots of vulnerabilities associated with it. It would be discouraged. It would be discouraged to use any of these versions, the SSL 2.0 and SSL 3.0. We see that with TLS 1.2, that is the highest rate here, 62%. A question might be, well, why wouldn't TLS 1.3, the greatest and most latest version, why wouldn't that have the highest percentage? You would expect everyone to want to use the highest version. Well, TLS 1.3, if I'm not mistaken, was released by RFC in 2018. So it's been about 4 years now. So perhaps for TLS 1.2, everyone is still used to using the TLS 1.2, and it's a slow transition of websites being reconfigured to support TLS 1.3 for its latest versions. You may notice earlier I said that I scanned over 600,000 domains, but if you add all these numbers up, it goes way above 600,000. So as I said earlier, HTTPS protocols can support more than one type of its version. So you can have a domain that can support TLS 1.0, 1.1, 1.2, and 1.3. And that's what this graph is capturing. But we see domains, 62% of domains use TLS 1.2. One last thing to mention with these mix of protocol support, that is actually not a good thing, because the reason we do these upgrades is because of vulnerabilities that were present. So if you support an earlier version, you give the attacker an opportunity to employ one of the vulnerabilities that existed for that protocol. So it would be best if we had a domain configured with only the highest version of its protocol. We don't want to start mixing protocol support, and that's actually what we see here, a mix of protocol support among domains. We want to stay with just the highest version possible to prevent any vulnerabilities. So now we'll talk about the results for HSTS presence in domains. So as you can see here, only 5% of the domains analyzed had HSTS, something that I talked about that can prevent the man-in-the-middle attack. Only 5%, while 95% did not have HSTS. So this calls into question and curiosity, why is this the case? One theory I came up with was perhaps maybe the education about HSTS isn't known enough yet in the community. So to support that theory, I actually did a survey, which we'll see in the next slide. And the survey was conducted among my employees at Savannah River Nuclear Solutions. My employees include IT professionals and computer science professionals. So I only conducted a study among them. And the question presented was, do you have any knowledge about HTTP strict transport security, HSTS? And as you can see in the results, this was done by SurveyMonkey. As you can see, the results here is that 20% knew about HSTS, while 80% did not know about HSTS. So that supports the theory that it's not enough education out there. If there was more education about HSTS, then it would be more likely that the domains having HSTS, as we see in the previous slide, would increase. So now we'll talk about the results of the scoring system. So with all the data analyzed, let's incorporate the scoring system that I talked about earlier. Remember, a passing score is when a domain is essentially TLS 1.2. We give that a 70. So anything higher than anything TLS 1.2 or higher is considered passing. So we see that 62% of the domains analyzed are passing. They have a decent setup for their protocol, while 38% is failing, meaning that their protocol setup is not very good at all. So the overall analysis of the results I just talked about, there's a positive trend for secure network protocol setup. We have more domains that have the right configuration than domains that don't have it. So at least we have a positive trend going there. And the same can be said with the positive trend for the scoring benchmark. We have more domains that are passing the scoring benchmark than that are failing the scoring benchmark. The third point, there's still a need for improvement though. It's not a high enough number of domains that have the best configuration. We still have at least a third of domains that need improvement. So there's always room for improvement. So for the conclusion, so the proposed scoring system is a quick and effective tool that can be used for any domain. So one reason behind this scoring system, there's a lot of scoring benchmarks out there, and there's even companies that their whole purpose is to do scoring benchmarks for domains, I found that with many of those scoring benchmarks, it's very, very, very detailed and granular with scanning different things about domains. It's very, very detailed. I just wanted to create a simple scoring system that could be quick and effective and giving us an idea of where a domain stands. So that's why this scoring system was proposed in this paper. We wanted to have something quick and effective for analyzing a domain. Second bullet point, HTTPS domains with lower version protocol support needs to be mitigated. So as we saw earlier, go back to the previous slide. As we saw earlier, there are domains that have different versions that can support different versions of the protocol when it comes to HTTPS protocol. We don't want that. We want to use only the best version. If we introduce earlier version support for domains, then as I said earlier, hackers can take advantage of the vulnerabilities that were present in those earlier protocol versions. And we do not want that. We don't want to present any opportunity for the hackers. So the third bullet point, more education about HSTS is required for it to be configured and used for domains. And as we saw earlier in our chart with HSTS, only 5% of the US related domains analyzed had HSTS. That's very, very low. And one thing to mention about HSTS is that HSTS was actually released in 2012. So there's been plenty of time. It's been 10 years now. So we definitely need more education in the computer science and IT community for HSTS, definitely. So one of the future things we can do for the future work for this is increasing the coverage of domains analyzation by getting the zone file from EduCause. So as I mentioned earlier, when I was gathering domains, EduCause had more strict policies when it came to giving out their zone file. They believed that the person requesting the zone file, they would only give it to the person if they believed that giving them that information would help their company in a significant way. Perhaps if we have more universities involved in this study and the universities present the request to EduCause, it can increase the chances of EduCause in providing that zone file. We want to have the best coverage for analyzing these domains to get the best results about the state of these US related domains. Another future work item includes performing this same survey type study in the next upcoming years. We can check to see if the positive trend is improving or not. We can also check if HSTS education is going on, has it improved? We can see if the HSTS presence has increased or not. We can see if more domains are trending towards TLS 1.3 since that's the latest version, or are many domains still stuck using TLS 1.2 or not? And with that, that is the end of my presentation.